Hi, my name is Josué Lopez and this is my statics project number 2. The purpose and objective. For this project we had to create a space lander using only spaghetti sticks and hot silicone glue and an egg as our crew member to simulate a Mars landing. My inspiration for my structure was the Apollo 16 extended Apollo lunar module, which would carry the 10th Crew Division. It is the first crewed spacecraft to operate in space and the only to land somewhere besides Earth. The lander has a polygon shape and a triangular chassis on the legs. I decided to create something similar to this lander. My objective is to create a structure that will prevent the egg from breaking, but also have minimum damage on the lander itself. My brainstorming process was to first decide on a polygon shape for my primary structure. I didn't know if I should go with a pentagon, hexagon, or octagon. I decided to go with the pentagon shape as it will limit the number of joints, as too many joints would cause the structure to flex too much. For the legs, I went for a triangular structure as I thought it would be the strongest. I also decided to create a cage on the center to prevent the egg from moving and reinforcing the structure. My final design came as wanted. The weight was 104 grams with the egg inside, the height was 7 centimeters, the radius was 8 centimeters. My performance was 1 divided by 0.104 kilograms, which equals up to 9.62. The egg survived the landing, as you'll see in the next video. For my calculations I began by finding the velocity using the kinematic equation v final squared equals v initial squared plus 2a times x final minus x initial, which came out to 4.43 meters per second. I then calculated the conservation of energy using the formula T1 plus B1 equals T2 plus B2. T standing for potential energy and B standing for kinetic energy. The formula for potential energy is mass times gravity times height, which gave me 1.02 joules. The initial kinetic energy is 0 as the object is not moving. The formula for kinetic energy is 1 divided by 2 m times b squared, which is equal to the potential energy of 1.02 joules. For my analytical calculation I used the force divided by 10 as there is 2 of these structures in each leg. Calculated the force acting on each truss of the structure. As you can see, the force acting on D to C is of 0.14 newtons, and the force acting from A to D is of 0.102 newtons. The force acting on C to B is of 0.14 newtons, and C to A and B to A are zero force members. I also made a simulation. This is a structure under a 1 Newton load. As you can see, the structure suffered of damage in 2 legs, which I believe is because of a design error I couldn't fix. In conclusion, I believe I accomplished my objectives as the egg was able to survive and the lander suffered of minimal damage of only 2 broken legs. I believe if the legs were to be connected to the center of the structure, they would be greater reinforced and would be able to survive, distributing the load even more. Another cause for the 2 broken legs would be the lander falling at an angle or an uneven surface, causing the legs to absorb most of the impact. In this project I learned the importance of brainstorming and prototyping to obtain the best results, I would like to see how the other shape structures would compare to mine.